applies to what we're about to learn, okay? So the whole point of this entire unit is to, we actually kind of talked about all of what's on this page just a second ago, so just come to here. Anyway, so the whole point of what we did in Unit 1, reviewing quadratics, was to be able to apply those ideas to upper level degrees. So basically, the whole purpose of this first unit, Unit 2, is learning how to factor x cubed, x to the fourth. Next unit, Unit 3, is going to be learning how to solve those things, okay? Now, in order to be able to factor next time, x cubes, x fourths, try not to miss next time, it's a tough lesson, okay? But in order to be able to do that, I want to take it a step back first, and I want to review going from a 0 to factored form to standard form. And then, so going from given parentheses to no parentheses. And then next class is where we're doing like the culmination of everything we've done this year so far, where we learn how to do like an x cubed, x to the fourth, standard form, no parentheses, and put it into all of its little factors, okay? So that's what we're building to. So a factor is the equation part of it. Okay, so today we're going to go from factors to standard. So it's the equation part. So like the one with the x in it. So x plus 2. The root is what makes the factor 0. You got to know the difference between those words to understand what we're doing. So that would be x equals -2 on this one. Does that make sense? So the 0 in root and x-intercept and solution and answer are all what makes my factor 0. That's why I only switch the sign when I put them in an equation. I don't switch the sign with the zeros, factors, roots, things like that. Does that make sense? Well, I got more answers that time. I felt less ignored, okay? Good. Let's go ahead and start with the roots. So if I have a root of 2, all right, then what's the factor that goes with that? The root is 2. So the root, what makes the factor 0 is 2. X minus 2. It has to have an x in it if it's a factor. Okay, what's the factor for if the root or the 0 or the x-intercept or the solution or the answer is -3? There we go, x plus 3. Got to have an x in it, okay? And then x minus 4, okay? So if I was going to write it out as a nice polynomial, I'd say y or f of x equals x minus 2 times x plus 3 times x minus 4. Now, this polynomial right now is in factored form because I see the factors. Now, you're going to see this phrase a lot in this lesson where it says of least degree. What that means is like, when I'm giving you a list of roots, some of them could have multiplicity that are bigger, right? Or it doesn't say these are the only roots. So I'm saying at minimum, I know because there was 3 roots, the least degree it could be is 3. It couldn't be a quadratic if I have 3 roots, right? Okay. Okay, what factor goes with 0? Ah, very good. Just x. And then x minus 5 and x plus 5. So if I was going to write it like a nice polynomial in factored form, could look like this. Does it matter what order I put all the factors in? No. Because multiplication is commutative. I'm going to make it a little harder. Any questions? No? What about this half of the class? Any questions? No. No, not yet? Okay. We're going to skip A. It's too easy. He said no. I got a response. Okay, so I want to start by writing this polynomial in factored form, but then I want to end by having this polynomial in standard form. Bum, bum, bum.
Wait, are we crossing out the first ones?
Yeah, that's what I said and did on the board. So, what's the factor that goes with negative 5? X plus 5 has to have an X in it for a factor. And then X minus 6 and X plus 6. Now that's the factored form, right? It has all my parentheses. I can see all my roots individually. That's the factored form. However, what I want to review to help prep us for next time is how to make that factored form turn into standard form. Now, whether you do a box or the claw or the arrows or however you foil, you can only ever do 2 parentheses at a time. All right? So you can pick any 2, but I'm going to do the first 2. Okay? So you can, if you want to do it a different way and you're showing your work, that's great. Okay? So again, I don't care if you use arrows or the box, but you can only ever do 2 parentheses at a time. Now this here is what I got when I multiplied out just those 2 first pieces. Here, I'll pause to let you catch up writing that down for another 20 seconds. For those watching the video, here's your elevator music. That's pretty good. I was recording a lesson for somebody in class today, and I did the whole I'm going downstairs thing in front of the camera. It was so funny. I'm hilarious. Colin agrees. I can tell on his face. Okay. Yeah. So the reason I show you that is because now this parenthesis has to multiply by my last one. So my box isn't going to be a 2 by 2 this time, right? What? Very good. 2 by 3 or 3 by 2, however you want to draw it. I'm going to draw it in the way that is easiest based on how much workroom I have right now. Oh, that was bad. What? In my office. I'll deal with it later. Oh, well, you can, I don't care where you put it. Yeah, that's fair. You are going to deal with it later. It's actually pretty organized where it is right now. I just need that cabinet for my outbox for that class. So x times x squared, x cubed. Remember, you only change the exponents when you multiply, not when you add. Okay, negative 1x squared, negative 30x, 6x squared, negative 6x. 3 times 6, 18, so negative 180. Ah. How are they doing, Mrs. Hooper, with this? Yeah, looks like people are following along, understanding. Be careful on your homework. Every year I teach this stuff, oh yeah, go ahead. What'd I do?
I think you missed the minus 6x.
Oh, I did. Good catch. That should be 36. Thank you. I love when you catch my mistakes. Means you're paying attention and you understand. I love it. Okay. Unfortunately, whether you do the box or the claw or arrow or whatever, there's no way to ever multiply more than 2 factors at a time. Okay? So you just have to always do 2 at a time. And it doesn't really matter what order you do them in. In the end, if you do your multiplying right, you'll get the same answer. Your middle one might be different if you do them in a different order, but your last one will always be the same, okay? Now, one thing just to save you time, you got to read the instructions, because like on your homework tonight, a lot of people just saw the factored forms and put them in standard form. Only half the questions say standard, the others say you can leave them in factored. So, I mean, I don't hate the algebra practice, but probably could have saved them 45 minutes, you know? So if you read just make sure you read your instructions. If it wants factored form, it's just like last year, parentheses. If it wants standard form, then you have to multiply it out, okay? Okay, let's stop here. Give me some feedback how we're feeling before I bring imaginaries into this context. Are we doing okay?
Yes.
Yeah? Okay, good. So, we had a trick that we reviewed last unit that you learned last year that I'll just remind you of real quick, called the difference of squares. So x squared minus 4. And then when it's a binomial like that, you don't have to actually do the box, because we know that if these are perfect squares and that's subtraction, then I can take the square roots of each one. Can you guys put some water in or not water, ice. Just fill it with ice. Thanks, friends. And then one's positive and one's negative. Now that trick only works if this is a subtraction, right? Why? Why does that trick only work if that's subtraction? Why does that trick only work if that's subtraction? Read.
Because 2 times negative 2 equals negative 4, no matter what.
Because 2 times negative 2 is going to be negative 4. Very good. Can anyone think of another reason? What's the only way to make the middle term go away and add to 0? The b. If one's positive and one's negative, right? Okay. So there's a version of this I can apply. Your teacher may or may not have done it last year. I'm not sure. But either way, it really goes close to it. That it will work for a plus, okay? Now, the trick still only ever works if I have subtraction. So what I'm going to do is I'm going to change my plus into a minus a negative. So now, because it's a subtraction, I know I can have my trick of taking the square root, and one's going to be positive and one's going to be negative. Does anybody remember what the square root of negative 9 is?
3i.
3i. Very good. So let's kind of bring it together from what we did on the first page. Oh, let me pause the video. Sorry. I like to break.